That's surprising.
All right. So, piecewise functions. Here's an example. You guys ready? Piecewise function is a function that follows multiple rules. Okay? It doesn't just follow y equals 5x plus 3. Alright? It's not just going to be one simple function. It's going to follow that function the entire time. Okay? It's going to have multiple functions going on at a certain time. Okay? A very real-world application of an example of a piecewise functions could potentially be, and it's not a concern to you, but essentially tax brackets right now. Okay? Based on the amount of money you make, you get taxed at a certain percentage. Okay? So here, this is how you would figure out how much tax you're going to be charged if you make so-and-so dollars. If you make this many dollars, now we're going to tax at this percentage. So your tax rate would follow different rules for different domains. You guys kind of follow what I'm saying there? Okay? We don't do a lot of applications with them, okay? But because I just want you to be comfortable with what piecewise functions are, what they look like, okay, and how to graph them in a sense. All right? So here's what this is saying. This is saying y equals the absolute value of x plus 3. But it only equals the absolute value of x plus 3 for x values that are less than or equal to negative 3. So if I said to plug in negative 5 for x, could I plug in negative 5 for x right here? Yeah. Yes, because negative 5 is what? Less than negative 3. So if x is negative 5, what does y equal? You tell me. If x is negative 5, what does y equal?
8.
8. Okay? No, excuse me. No, sorry. No.
2.
2. Yes. Negative 5 plus 3 is negative 2. But what's the absolute value of negative 2? Positive 2. So when x is negative 5, y is positive 2. How about when x is negative 10? Vicky?
7.
Y is 7. Okay? JP, how about when x is negative 3?
It's 0.
0. How about when x is 0? Can I plug in 0 right here? No. Because it says I only follow this rule when x is less than or equal to negative 3. So I don't follow this rule when x is 0. What rule am I going to follow when x is 0?
4.
The middle one, right? Y is equal to 4 for any x value that is greater than negative 3 but still less than or equal to 2. So if I plug in 0 for x, what do I get for y? 4. If I plug in 1 for x, what do I get for y? 4. If I plug in 2 for x, what do I get for y? 4. Any number, if x is any number between negative 3 and positive 2, the y value they're saying is always equal to 4. Okay? What if I need to plug in 10 for x? Where do I do that? Down on the bottom, right? 5 minus 10 would be negative 5. So when x is 10, y is negative 5. So far, so good? Okay? So, here's kind of how this website is saying this. Y equals the absolute value of x plus 3. That only works for x values less than or equal to negative 3. So they're saying that function lives over here. It lives everywhere where x is less than or equal to negative 3. Y equals 4 lives in this space. Y equals 5 minus x lives in that space. You guys kind of see that? Any questions on that? Okay, get it all on screen there. This graph is going to live here. That graph's going to live here. This graph's going to live here. Okay? All right. So, we're going to graph y is equal to the absolute value of x plus 3, but we're only going to graph it for x values that are less than or equal to negative 3. So a lot of times what I'll just do is I'll make a table of values, right? So I'm going to follow this rule for x values that are less than or equal to negative 3. So if I make a table of values, what values do you think I'm going to use for x? Negative 3, negative 4, negative 5, and so on. Alright? If I plug in negative 3 for x, I get 0 for y. If I plug in negative 4 for x, I get 1. That's 2, that's 3. So then I could go look at the graph of it and make sure it's hitting those coordinates. Negative 3, 0, negative 4, 1, negative 5, 2, negative 6, 3, and what's it's going to continue to do as we go that way? It's going to head up in a nice linear path, right? Okay? So there's the graph of y equals the absolute value of x minus 3, but I'm only graphing it over here because I only follow that rule when x is less than or equal to negative 3. Okay? The next one says y equals 4. It says y is equal to 4 for these x values. Well, what does the graph of y equals 4 look like? Y equals 4? Just a horizontal line of 4, right? Y equals 4. So all you're going to do is you're going to see a horizontal line at 4. Why was there an open circle right here?
Can't be negative 3.
Okay? Yeah. We only follow this rule for x values that are greater than negative 3. So that means at negative 3, am I following this rule? Will that be filled in? No, because at negative 3, what rule was I following? The green one. Once I got to the right of negative 3, then I was following this one. All the way until x equaled 2. So that one's filled in because I'm still following the rule y equals 4 once my x values get to 2. Okay? And then you kind of finish it off with the last one. Again, y equals 5 minus x, or negative x plus 5, however you want to think of it. And I only follow it for x values that were greater than 2. Now, what I would still do on that one is when I make my table of values, I would still start at 2. Okay? I would still start at 2. But I just know that that has to be an open circle because I'm not following this rule when x equals 2. I'm only following that rule when x is greater than 2. So I just make an open circle on that one and plot the rest of the points. Okay? So that's just kind of a real quick summary of absolute value functions. So here's what a function, a piecewise function would look like. This one has 3 parts to it. So the graph is going to have 3 parts to it. Ringing a bell, questions, talk to me, give me a little feedback. We're doing a little bit. Okay? Alright. Let's go ahead and let's try this one. Alright, so y equals 3 when x values are less than negative 1. What's that going to look like? Horizontal line up at 3. But am I going to just draw one big horizontal line all the way across my graph?
At negative 1.
No, when x is at negative 1, that's where I'm going to start. And is that going to be an open circle or a filled-in circle? Right
Open.
there? Open, and the horizontal line will be left or right of it?
Left.
Left of it. There's my line, y equals 3, but I'm only graphing it for x values that are less than negative 1. Here's where my x value equals negative 1, right up there. I don't graph it when x equals -1, but I go all the way right up to it, so I have an open circle right there, and I just have a nice horizontal line all the way going left forever, because for every x value that is smaller than -1, my graph will be just simply y equals 3. Yes, no, questions? Okay?
Yeah.
Alright. Next one. I'm following this rule for every x value from -1 to +1. Okay? How many of you know what this graph looks like right off the top of your head? Probably not many. Some of you should have an idea. What shape will it be? It's got an x squared in it. It's a parabola, right? Okay? It's a parabola that's shifted 1 to the left and 2 down. Remember shifting things, left, right, up, and down? The parent function would be y equals x squared, right?
Yeah.
The x plus 1 in the parentheses would shift it 1 left, always opposite what you would think. The -2 afterwards shifts it up or down exactly what you would think. Okay? Some of you don't have that memorized, that's fine, so make a table of values. Alright? We're only graphing this one, though, for what x values? From where to where?
-1 to +1.
-1 to 1, so let's use -1, 0, and 1. Right? If I plug in -1 for x, -1 plus 1 is 0, 0 squared is still 0, take away 2 would be -2.
Yeah.
Plug in 0, 0 plus 1 is 1, 1 squared is 1, 1 minus 2 would be -1. Plug in 1, 1 plus 1 is 2, 2 squared is 4, 4 minus 2 is 2. Okay? So -1, -2, 0, -1, 1, 2. There's that parabola. If you were going to graph the whole thing, you know, it would look like this, right? But we're only graphing it from the x value of -1 to 1. Okay? So far?
Yeah.
Alright. And then the last one, y equals x minus 4. What's that graph going to look like? It's a line that has a slope of 1 and a y-intercept of -4. So some of you can do this one without making a table of values because you know what it looks like. It's a line that has a slope of 1 and a y-intercept of -4, but I'm only going to graph it for x values that are greater than 1. Some of you could probably draw that right now without even making a table of values, but I will make another table of values because that's the way some people will do it. Okay? So for that last one, I'm going to make a table of values. What's going to be my first x value that I use? I would still use 1.
1.
But I just know that when I plug in a 1 for x and I get -3 for y, 1 comma -3, what am I going to put there? An open circle. Because I don't actually follow this rule when x equals 1, but for every value where x is greater than 1, I will follow that rule. Plug in a 2, I get -2. Plug in a 3, I get -1. Plug in a 4, I get 0. So it's got up 1 over 1 qualities there. So the graph ends up looking like this. And there's an example of your piecewise function.
Can't we draw like the little boundary things?
If you want to draw boundaries, that's fine, yes.
Okay.
Understand they're not really part of the graph, but if it helps you to distinguish what belongs where, that would be fine. You draw them very lightly. Okay, good question. What else do you have for questions on that? Graphing piecewise.
Sure.
Okay?